Hey everyone, welcome to part 4, Automate Model Training. In this video, we're going to complete this exercise, which asks us to complete this function, which will automate all the work from the previous video. So let's go ahead and read what this exercise asks us to do. So we're going to write a function that accepts a series of data, that'll be S. The last date to use for training the model, that'll be last date. The evaluation function, that's the model itself. The bounds for the parameters, the initial guess for those parameters, and then any extra keyword argument that would be forwarded to the least squares function. So what we're going to do is also assume that the optimized function is already defined and is available in our namespace. That's a clue that we need to use that in this function somewhere. We're going to build a model using the least squares function, and then we're going to turn an array of the fitted parameters. So like many of these exercises, the hard work has mostly been done, and it's been done in the notebook above. The function is just merely to encapsulate all that work into a single area that we can call it over and over again with different inputs. So if we just scroll up here to the work we did in the last video, we're just going to replicate this first part, which is the training of the model. So specifically, we use Texas cases up to a particular date, and then we trained the model using the least squares function and with these parameters. So let's go ahead and come down here, and we'll just copy and paste these lines of code, and we're going to just substitute in with our more generic parameters that we use. So instead of Texas cases, we're going to use any series of data. Instead of this specific date, we're going to give it the last date. Now the x values will remain the same. The y values are gotten there. So this optimized func, that's what least squares requires. And if you forgot what that was, let's quickly scroll back up here to where the optimized func was defined. So you give it the parameters, for the model, the x and y values, and then the model itself. So it'll compute the prediction and then calculate the error and return that error. So that's what we're trying to optimize. That is what the least squares is trying to do, is make that function as small squared values as possible. So we're going to pass in least squares the initial guess that's given by the user in this function. We're going to pass it this tuple of arguments, x, y, and instead of simple exponential, so this is a function of our basic exponential. We can give it any model we want here, so that's great. And that's the whole point of this, is to make the work generic so that we can apply it to a vast array of series and models. And then the bounds, well, that'll be given over here as well. So that's all we need to do. The last thing is just to return the x attribute of this object that SciPy returns us. So that'll be the fitted parameter values. Let's go ahead and execute the function to put in our namespace. So we'll just use our Texas cases that we did above. We're going to set the last date. Our model was defined above, this simple exponential model. The p dot and p bounds were also defined in the last video, so let's go ahead and just use the same ones again. And so that's it. We get our fitted model parameters. So we've trained our model, and this is what it told us those parameters are. Okay, so that's it for part 4, Automate Model Training.